All right, well, thank you everyone for being here this afternoon. I know it's late and I'll try to be quick for you guys. I think we have some really interesting information to share with you though. I'm with Concurrent Real Time, and we are big supporters in the space community, flight software applications in terms of real-time computers. And let me take you through a little bit of information about us. We have been around for 50 years. We're a US-based company out of Pompano Beach, Florida. And our foundation, our specialty is real-time Linux, completely compatible with Red Hat, Centos, or Ubuntu. And we specialize in software applications for simulation and data acquisition. We do have a factory down in Pompano Beach where we provide many of our customers with fully integrated Linux systems, although we do offer our real-time Linux as a software-only product. And we're used to long-term lifecycle support. We pretty much have been supporting military programs and programs that have very long requirements for a long time here. Now, I'm going to tell you a little bit about who some of the customers are that use this, including the people right here in this building, to see if it can relate to any of the applications that you guys are involved in. So right here at Johns Hopkins, we started out probably 15 years ago working with the people across the street doing missile applications. And so what they're doing over there, it's hardware-in-the-loop simulation of missile guidance systems. So what they're doing is taking the actual guidance system to a missile, connecting it to our computer with analog inputs, analog outputs, all kinds of I/O, 1553s, A-Rink, and basically simulating the entire environment so they can develop the software that goes in the controller. And essentially, if you think about it, they can do a missile launch in the laboratory. They can teach a missile to take out a new threat in this way, doing this hardware in the loop. And then the guys in this building learned about us, and we're now supporting the solar probe application, the spaceship solar probe. They have about 8 test stands, and they've done their flight controls. All different aspects of the development of the control systems of solar probe have used our computer systems to do that. And then another one that's sort of similar to Johns Hopkins, or really a competitor, is Draper Labs at MIT. So Draper has been another customer of mine for 20 plus years. I'm a little unique in the industry in that I've been with my company for 32 years. So I don't think you'll ever meet another salesperson who's been in one place that long. But Draper, tremendous relationship. All of their simulation, real-time computing requirements are done with our technology there. And that led us to working with General Dynamics in Western Massachusetts because the initial work was done on the Trident program, which are nuclear missiles for submarines. And the launching systems are done in Pittsfield. But General Dynamics in Groton, Connecticut, they're a big customer too. They do submarine applications. Just a couple of examples. And Raytheon up in Boston, lots of applications in real time for sonars, additional missile systems, some weapon systems out in Tucson, Arizona. All of this it's all hardware-in-the-loop simulation done with our real-time technology. Northrop Grumman, another large customer using us for radar applications in this particular example. Here they've taken our real-time Linux and they've deployed it. And it's actually running a spy radar that's protecting our Navy ships. And then in addition, I work with some folks at Northrop in upstate New York, near Buffalo, where they're doing a lot of avionics simulation. And in addition, infrared electro-optic applications. But I would say Lockheed Martin is our single largest customer today. And Lockheed is using us on many, many programs. And some of the ones we're most proud of are like the Aegis program. And this is where our real-time Linux is actually deployed on the Aegis ships. We're running the spy radar and weapons control applications, along with many of these others. What I'm going to talk about next is just, well, a little bit about Aegis, just a little blurb. They've successfully used our technology for years. We used to be PowerPC and Unix, and about 15 years ago we moved to Linux and Intel. So we've had a tremendous relationship with the Lockheed folks on Aegis, and that's worked well. We're also very involved in the THAAD program, another missile program out in California. It's all simulation, hardware-in-the-loop applications out there as well. Now, before I proceed, I wanted to also mention some of the space applications and some of the places you guys might be from. But United Launch Associates out in Colorado, they use our technology for ground control, hardware-in-the-loop for the avionics for the Delta and Atlas rockets. Lockheed Martin out in Colorado also uses this for a variety of satellite applications from GOES-R, Arias, Rex, Maven, GPS-3, MP3, Block 3, and also for the Orion space capsule. And then another one that we work with is Sierra Nevada out in Colorado for the Dream Chaser cargo vehicle. And their control systems and the simulation is all done with our technology there. And then the big one is NASA. NASA in Huntsville, Alabama has over 500 of our computers being used for the SLS rocket launch system and all kinds of avionics testing applications. So we're very much in the space community, and anybody who needs real-time simulation or an embedded real-time operating system would like you to consider this. Now we do support x86-based platforms, and we do offer fully integrated Linux servers to our customers, but we also have support for single-board computers. The server class computers, we call these iHawk systems for sort of an Intel-based computer. Commercial off-the-shelf server systems, very popular with our customers. And one of the interesting things is we can help populate these systems with whatever I/O you might need, from SpaceWire to TT Tech cards, which we have outside, to A-Rink, CAN bus. All those types of I/O can be included in these systems and made to work. We also can support any of these other third-party companies who build single-board computers. So this real-time Linux would run on compact PCI, PC104, VXI, VME, any form factor, as long as it's x86. And recently, we've actually put RedHawk on ARM64 to expand our reach into more of the embedded community for autonomous vehicles. Now, I'm being very brief to just sort of introduce this to you guys today. What this RedHawk Linux is, it is a absolutely true real-time low-latency version of Linux. It is our solution. It's an absolute comprehensive solution for multi-core embedded systems. We've always been focused on multiple processor type computers. So this works extremely well on all the latest processors that are multi-core. It does satisfy requirements for both soft and hard real-time requirements, high reliability. And then the thing that we bring to the table too, it's not just a real-time operating system, but it's a complete tool set. So an example of a perfect customer would be somebody using VxWorks and PowerPC, and if you want to go to Intel and Linux, we can completely replace VxWorks with this real-time operating system, give you the same level of performance and a set of software development tools for Linux developers that is far superior to what you guys had before. Now, the RedHawk Linux operating system is one component of our technology. We also have an architect tool, and the architect is a tool that allows you to create a small image of Linux that makes it easy for you to deploy it on single-board computers and then deploy it across your environment. Another component is the NightStar tool set, and I'm going to tell you what those are, but that's our suite of software development tools that Linux developers use to do non-intrusive debugging, data analysis, tuning of the system, and a time trace. Our company provides professional services, and we have customer service and support scattered around the United States, but we are an East Coast company, so if you're on the East Coast, that's the time zone we're on. So RedHawk itself, the thing that makes people comfortable with this, it is completely compatible with Red Hat, CentOS, or Ubuntu. What we've done is we've taken a kernel from kernel.org, we've applied our real-time changes to it, and for example, you boot that inside of Red Hat Enterprise. So from your point of view, you can't tell that you're not using Red Hat. You can't tell that you're not using CentOS or Ubuntu. And the customers are very comfortable with it, and it's absolutely optimized for determinism performance. So our definition of real-time is when it's important to you to have a program that executes in the same length of time every time in microseconds, and something that would respond to external interrupts in microseconds and would have very low latency. In fact, Wall Street uses RedHawk for high-frequency trading. Wall Street has pulled us in after they've heard what we do for customers. So we've had this for a long time. It's extremely mature. Our company, like I said, we've been around for 50 years. We've had our real-time Linux for 15 years now. And we use some of the open source patches, but then a lot of the technology is ours in terms of what it took to make this real-time operating system work properly. Now, as I mentioned, it is built on the 3 distributions listed on the top there. We are compatible with the latest version of Red Hat. We do give customers 3 versions of the kernel. You do get all the source code, so it is considered open source software. Most of the customers use what we call a trace kernel. We've instrumented the operating system with trace points, so you can do a time trace analysis on the operating system in your application. You essentially have one of our tools gives you a window into the computer where you can see what's happening on every core on a nanosecond timeline with no special hardware required. And essentially, you're getting transparent performance enhancements and everything in Red Hat, CentOS, or Ubuntu, plus our real-time kernels and performance. Now, in terms of where we are with different versions of our software, people might be interested. We have our numbering scheme matches Red Hat. So RedHawk 6.5 means it's the same as Red Hat Enterprise 6 Update 5. We're up to 7.3 right now. We're coming out with 7.4 early next year. So we're up to Red Hat Enterprise 7 Update 3. And the other thing that's interesting is we're typically using a newer kernel than Red Hat. So if you're a Linux programmer, you might recognize that, our 7.3, that's actually a typo. We use a 4.4 kernel. 4.9 is for our next release. But it's a newer version than what Red Hat uses. So we're always staying on top of the technology. And we also have this automated nightly testing system where we're always testing the software every night in an automated fashion on all of our computers in our labs. Our approach to getting the best real-time performance is something called CPU shielding. Now, this is something where the concept is basically we suggest that customers move Linux, the daemons, and all the interrupts off to core 0, and all the other cores in the computer are shielded for you to use. So these shielded processors will run your real-time application, and they'll run them uninterrupted. Now, it is true those constructs are available in standard Linux, but they don't work in terms of your applications will get interrupted. You can't control all the interrupts the way we can, and you don't get the levels of latency and performance that RedHawk gets you today. So all of this technology essentially means that using this, it's transparent to you. Your application can be put in this environment, and you don't have to change your code, and you're going to be running real time. So people like it for that as well. Also, all this control you have for CPU shielding, and we give you the ability to easily vector interrupts to any particular core. It can all be done dynamically while the system's running, which is pretty cool. Moving along to some of the other features that we offer, if anyone is doing CUDA programming, or basically taking advantage of massive parallel processing on NVIDIA cards, we have modified the NVIDIA driver to support real-time while doing CUDA programming or GPU programming. So our customers take advantage of this, and you can do this with the Tesla cards from NVIDIA in these servers, or most of the NVIDIA graphics cards all support CUDA. So we want to be known as the company to go to if you need to do CUDA in real time simultaneously. In addition, our software development tools are CUDA aware. So, for example, we give you the ability to see how long your CUDA applications are taking in microseconds or nanoseconds on the computer system. One example of a customer who's using this is the Naval Underwater Warfare Center in Newport, Rhode Island. The guys in Newport design the guidance systems for torpedoes. And in their application, they take clusters of our computers, put them together, and apparently to simulate underwater, there's lots of FFTs, a tremendous amount of math that goes into it. So they're doing CUDA for their application. The NightStar tools. This is typically, when we show this to people, the thing that drops jaws and say, we have to start using this stuff immediately. Now, I'm just going to tell you about them today, but if you guys are interested, we can show them to you outside. But the tool set that we bring to the table would be familiar to somebody who was using VxWorks. So we have NightView. It's a source-level debugger. What makes our debugger different than the free debuggers that come with Linux? It allows you to debug your programs in real time while they're running. So what we're able to do is essentially hot patch your program in assembly language while it's running. We can talk to it. It's pretty interesting the way that works. You can actually change lines of code in your program while it's running without recompiling. You just type in the new line of code, you hit enter, and we've just changed your software, and you can see how it's changed. The next one we have listed is NightTrace. NightTrace is a software logic analyzer. It is absolutely a window into a Linux computer system or ARM64 that lets you see what's happening on every core on a nanosecond timeline. You can see every interrupt, every exception, every system call, every thread, how long they take. And there's a whole statistical analysis component to it so that you can see statistically where maybe something took too long. You can put the mouse on that point and see exactly what happened inside your computer on all the cores. In addition, you can put trace points around a subroutine of your own. So you can insert trace points yourself into your own code to look at a timing problem and to figure out a timing analysis. If you're doing real-time programming, a tool like this is absolutely indispensable because what the customers tell us, it's 2 weeks before you have to deliver this thing to the customer and it doesn't work. You have a timing glitch. How do you fix it? With a tool like NightTrace, you trace the system, you see what's going on, you can see where the timing problem is coming from, and you have the opportunity to correct it. NightSim is a graphical user interface into a frequency-based scheduler that we have in the system. NightSim is used by our simulation customers. It gives you an easy way to schedule things at a thread level to run at whatever rate you want on whatever core you have in the computer. And then NightProbe is a data monitoring, data recording tool. So while your application's running in real time, we give you the ability to peek and poke into the address space of your application. Your application has no idea you're looking at it. And then you can also record that information off to disk to analyze it later. And then NightTune is a system optimization tool that gives you a nice graphical user interface into that CPU shielding that I talked about. It gives you a nice, easy way to vector interrupts to a particular core, to essentially optimize the system's load to make sure that you're utilizing it correctly, to make sure you're taking advantage of all the CPUs correctly. So that's the NightStar tool set. And obviously, you know, the benefits to the customers: reduces project test time, increases productivity, lowers costs, solves difficult problems quickly. Now, we have another layer of a software solution that runs on top of these systems called Simulation Workbench. We're partners with the MathWorks, and we've noticed in industry lots of companies are using the MathWorks to model complex systems. We essentially have the ability to take a Simulink model, bring it into Simulation Workbench, automatically extract the variables out of that model, and easily give you an interface to connect a variable in the model to I/O going in and out of the computer to do hardware or man-in-the-loop simulation. So it's a complete simulation framework for Simulink or about a dozen other modeling packages that you might be using. Very popular with our commercial customers doing any kind of simulation. And I'm not going to take you through all of this information. Leverages Simulink and other tools for rapid prototyping. And we are showing it right outside on the computer. It supports commercial off-the-shelf hardware, all kinds of I/O points, 32, 64-bit versions of MATLAB Simulink, and works with RedHawk Linux. Has all kinds of great capabilities. So in summary, I know it's late, you guys. I appreciate the opportunity to share with you guys. We'd like you to consider us if you have any requirements for real-time computing, real-time simulation. Our value adds are in our tremendous expertise in helping people solve difficult problems with Linux where timing matters to you. So if timing matters, give us an opportunity, and we have some great references right here at Johns Hopkins using this. So that's what I wanted to expose you to today, but thank you very much.
Thank you very much.